And we're back for the last video of P4. We're going to finish the rest of the exercise we're going to look at today. This is exercise 49 on page 29. Just continuing on from the problem we did at the end of last video. Along the same lines. If you want to add or subtract radical expressions, you need to simplify the radicals first. So if you break down 16 is 8 and 2, 8 is 4 and 2, 4 is 2 and 2. So that's 4 2's, so we have the cube root of 2 to the 4th times a to the 5th. 3 goes into 4 once, so I get to bring out a 2. Remainder of 1, so I have to leave a 2 inside as well. 3 goes into 5 once, so I get to bring out an a. Remainder of 2, so I have to leave a squared inside. I don't need to put absolute value on this because this is an odd root. Doesn't look like I have to do anything at all to the second root there. 3 cube root of 2a squared. Now, these aren't really like terms because they have different variable expressions on them. This has an a in front of the root, this one doesn't. And this is what I would expect from you guys on, say, a test. But I'll tell you what WebAssign wants. It generally wants you to go ahead and take it one step further and do a factoring out step. Alright, kind of explain why. When you do combining like terms, the reason you can do it is you can factor out the common x and then you can add them. And that's a nice thing to be able to do because that means you can still solve for x even if you have something like the square root of 3 plus the square root of 5. Because then you can still factor out the x and then divide by that parentheses to solve for x. Well, they want you to do that first step of factoring out the common root. So we would have 2a minus 3 times the cube root of 2a squared. And that would be our final answer. Now we're going to look at exercise 63, page 30. This is our first problem dealing with rational exponents, fractions in the exponent. They just want us to simplify this. Well, let's see. This is basically just going to be using rules of exponents. We know if you have an exponent outside of parentheses, it does distribute through. So 4 to the 1/2, b to the 1/2. There's no exponent outside this parentheses, so I just get to rewrite that one. Times 8 times b to the 1/4. Now let's see what we can do. 4 to the 1/2 is just 2. These 2b expressions, I can just add their exponents, because remember, if you multiply two expressions with the same base, add their exponents. So 1/2 plus 1/4. Get common denominators, you have 2/4 plus 1/4, which equals 3/4. I have 2 times 8 times b to the 3/4. And that will get us 16 b to the 3/4. Moving on. This is exercise 71 part B from page 30. Along the same line, it's just a little bit more complicated. First thing we want to do, order of operations. If we can do anything inside the parentheses, certainly we should, but I don't really see anything There's no common variables that I could reduce between. So it looks like I'm going to have to apply these exponents first. So the exponents will distribute through, as they do. So 4 to the 2, y to the 6th, z to the 2/3, so I'm going to have to multiply 2 over 1 times 2 over 3. That would be 4 over 3. That would be z to the 4/3 over 2 times 1/2. I don't need to do a sidebar 4. That's just going to be x 1/3. 1/3 times 3 is just 1. So times x to the negative 1. 1/3 times 6. So that's 6 by 3 to get 2. And y to the 2. 8 to the 1/3. And if you multiply a whole number times a fraction, it's just going to multiply into the top, because, you know, 4 over 1 times 1 over 3. So that'll just be 4/3. Z to the 4/3. First thing I see that I can reduce is the z to the 4/3. Four squared is 16. Combine the y's, get y to the 8th. I'm going to subtract the x's on the bottom. So that'll be x to the 1 minus negative 1. Because remember, it's a division. You subtract them. Remember, if you subtract them on the bottom, it's the bottom exponent minus the top exponent. If you subtract on the top, it's the top minus the bottom exponent. Times 8 to the 1/3, that is the cube root of 8, which is 2. My final answer then should just be 8, as the 2 reduces with the 16. Y to the 8th over x to the 2. And we're moving on. Several quick fire exercises here from page 30. 90C. On these problems, we are rationalizing the denominator. What that means is we are trying to get the root off of the bottom. Rationalize the denominator literally means turn the denominator into a rational number. So that's what we're going to do. Need to get rid of this root? Well, how do you get rid of a square root? If the inside is a square, it'll reduce away. It will simplify away. We've seen that many times. That's not hard to do in a fraction, as long as I don't care about the numerator. Because as long as I do the same thing to the numerator and denominator, I can multiply by anything I want. So I'm going to multiply the bottom by square root of 6. When I do the bottom, I have to do the top. I don't care about the top. So now I haven't changed the number because I've just multiplied it by 1. Square root of 6 over square root of 6 is 1. But the top is now 2 root 6. And the bottom is now 6. Because square a square root, the root's going to go away and you're just going to get what's inside. And then I can reduce that. 1, 3. Square root of 6 over 3. And I have now rationalized the denominator. That's often a part of simplification as well, so keep that in mind when you're finishing up your problems. If you have roots on the denominator, you should think about trying to rationalize those fractions. This one on the bottom here, 91b. It's not quite as simple, but it's the same idea. You have the 4th root of 3. Well, I need a 4th power inside a fourth root if the fourth root's going to go away. I have 3 to the 1. I need it to be 3 to the 4. So I'm going to multiply by what I need then. I have 1. I need 3 more. So I'm going to multiply by the fourth root of 3 to the third on the top and bottom. On the top, I'll just get the fourth root of 3 to the third. On the bottom, I will get the fourth root of 3 to the fourth, which, as we said, is just going to give me 3. I now have a rational number on the denominator and an irrational number on the numerator, but that's fine. We're just trying to get rational numbers on the denominator. 3 to the third is 27. And the very last problem for the day is this one, just like the last one. There's 2 ways of approaching this one. You could say, well, I have 4 to the 1, I need 4 to the 3 if I'm going to get the root to go away. But if you think about it a little bit, you might save yourself a little bit of time. 4 is already a power. 4 is 2 squared. So if I want to get a perfect cube on the bottom, I don't have to multiply by the cube root of 4 squared. I can just multiply by the cube root of 2. Because then I will just get 2 on the bottom, and I will have the cube root of 2 on the top. That's what I would get if I multiplied by the cube root of 4 squared as well. You just have to do some simplification at the end, some reducing to get there. And that's it for this lesson. Hope you enjoyed it. Next time we'll talk about algebraic expressions in P5. Good luck with the homework. I will talk to you in the next lesson.